All right, let's do another example. Most folks, when they buy a home, they need to take out a loan from the bank because homes are very expensive, and oftentimes folks don't have that kind of cash laying around in a savings account. So when you buy a house in 2012, you need to take out a loan for $180,000. And you make an agreement with the bank that you are going to pay that loan back at a rate of $7,500 a year, or $7,500 every year until you pay off the entire loan and you don't owe any more money. Usually, when you take out a loan, you have to pay back more than what you took out. That way the lender actually makes some money. But this is going to be a very, very friendly banker. Maybe it's a family friend or something, and they're going to make this loan at 0 interest. So you don't have to pay back any interest. You get lent $180,000, you pay back $180,000. So let's create an equation to describe the relationship between the number of years since 2012 or after 2012 and how much you owe the bank in thousands. So we're going to give these quantities some variable names. We're going to go with the highly original x and y. And I think that we can probably create this equation using mostly intuition. And this is very similar to some of the equations we made earlier. So let's try and take a crack at it. So I think that the amount we owe the bank, well, right in 2012, when x was 0, I think we owed $180,000. And we pay back the bank, and so how much we owe goes down and down and down and down, right? When we pay the bank back, we owe less. And we pay back the bank how much, how fast? We pay them $7,500 every year. And so that's how we can come up with this equation. And now that we've got this equation, it tells us the relationship between how many years it's been since 2012 and how much we owe the bank. So for instance, we could use this equation and say, well, how much are we going to owe the bank in 2027? Well, in 2027, well, how many years has it been since, well, what do we take out the 2012? How many years has it been since 2012? Well, it's been 15 years. That's the idea. So all you'd have to do here is you would substitute in 15 for that variable x. And of course, right in the year 2012, we started by owing $180,000. We pay back $7,500 a year for 15 years, and you will find out how much you owe the bank. And we find that in those 15 years, we pay back a total of $112,500. And I'll be honest, I paused the video and I did a little side work over here, but that's neither here nor there. And so how much do we owe the bank after that? Well, we owe them, let's see, $67,500. So in the year 2027, we predict that we'll owe the bank still $67,500. Not so bad. We could also use this equation to determine when we pay off the entire loan. Right? Paying off the entire loan just means that we owe no more money. So we substitute in a fat 0 in for that variable, representing how much we owe. So we've got 0 equals 180 minus 7.5x. 7.5x equals 180. Oh boy, what's 180 divided by 7.5? Let's see, 180 divided by 15 will be 12, so if we divide it by 7.5, it should be 24. So we get kind of the answer, the solution to this equation is x equals 24. What does that mean? It means that we'll pay off this loan 24 years after 2012. So namely, in the year 2036. So in 2036 would be the year. Hurrah! Okay, awesome. But I want to make another equation to describe this relationship. And this is kind of an added complexity to what we've done before, in which I want our independent variable no longer to be the number of years since 2012. I want it to just be whatever the year is. So you just tell me a year, and I don't have to do any thinking. I just kind of substitute in that year to our equation, and we're good to go. And our dependent variable will still be how much we owe the bank. Now, here's the thing. Okay, let's think about what this is going to look like if we were to draw a rough sketch of this graph. So here's our very rough sketch that we're going to draw. And so we know that in 2012, we owed the bank $180,000. So that's kind of like pseudo the starting point for our graph, if you will. And then I know that we pay off the bank. So we owe less and less and less every year. And so I'm just going to draw a downward sloping line. Now, how much less do we owe the bank every year? Well, every year that goes by, we owe the bank $7,500 fewer dollars. And of course, this pattern is going to repeat. Every time we go one further year into the future, we owe 7,500 less, again and again and again. And so this 7.5, or even more accurately, this negative 7.5, that's the slope of this line that's describing our relationship here. And remember, we always describe the slope as the change in our dependent variable over the change in our independent variable. For a 1 unit increase in time, in 1 year, you owe 7.5 thousand less. So perhaps I could have even been more accurate and made a negative 7.5, a negative 7.5, a negative 7.5. Okay, so we've got the slope. The slope is negative 7.5. I mean, that's pretty awesome. If we could only find a point that is on this graph, we'd be home free. Well, you know what? If I look right here, I think I see a point. I think I see the point 2012, comma 180. Phenomenal. So that's one way to think of it. You now have a point on this line that we're going to use to model the situation, and you have a slope. Boom, you've got all you need to make an equation in point slope. You can also think of this in terms of a table of values, in case this makes more sense to you. And I'm going to use a different variable here. We're going to call this variable n instead of x, just so we kind of make sure we know everything that's going on. In an NY chart, right, so we started at 180,000 and we went down by 7,500 every year, 157.5, 150, and this is going to continue. And of course the year would be 2012, 2013, 2014, 2015, 2016. And so we say, well, how can we use this table of values to create an equation to describe the relationship? Well, it's almost the same as what we had before. It's almost the same. And this equation is actually going to be y equals 180 minus 7.5. Now, we're not going to be multiplying 7.5 times x. Right? That would be the case if this were 0, 1, 2, 3, 4. But we're going to be multiplying negative 7.5 by x minus 2012. Right? This right here, it's not x, n, excuse me. This right here, this expression, n minus 2012, that represents the number of years since 2012. And you can see how similar these two equations are, and you can also confirm by substituting in some n values that this equation accurately describes this relationship and this graph as well. And I just want to make a note that this is probably the best form to put this equation in. If you went ahead and distributed this 7.5, you get a ridiculous number. And that number would be like our y-intercept when n equals 0. When the year equals 0, I mean, that could be kind of birth of Christ status. And we're really not so worried about the year 0, birth of Christ. We're really concerned with years beginning in 2012. So this would be the best way to capture that relationship.